Thanks for the invite. I always feel a slight fraud coming here because you all do millions of minutes and long-lived projects, and all of mine projects are short-lived and tens of minutes. But nonetheless, some of it is hopefully interesting. And this one is about, I found myself doing some weird stuff in the browser because I didn't have a media server. And so this is basically talking about what that means. And it's maybe also drawing to your attention that the WebRTC API and in general the web APIs aren't static. The W3C keeps adding stuff, and in particular Chrome keep adding stuff that might actually turn out to be useful for you. So for those of you who don't know me, I'm Tim Panton, I'm the CTO at Pipe. I wrote a while ago a WebRTC stack for running on small cameras, and it was like just destined for baby monitors, but it turned out that it's now being driven around the track in race cars. It used to say 250, but now it's 300, because yesterday I clocked a car doing 300 kph in southern France. So yeah, it's a race car camera that we've been working on. It sits over the driver's shoulder. It feeds live audio and video at low latency to the pit crew. So it's not for broadcast, it's so the pit crew can look over the driver's shoulder and see what they're doing and give them advice over the radio. So you need low latency, and the range of this thing is too far for Wi-Fi, right? So the tracks are 5 kilometer diameter typically. And the cars move at high speed. So we end up using public networks, public 5G networks, to do the backhaul, the uplink. This is what it looks like and sounds like when it's running. So just to give you a sense of how crazily they drive. I find myself watching this stuff every now and then and being scared, but anyway. So this is the architecture, the kind of context for the architecture we're talking about. You've got an ARM SBC running our WebRTC stack, talking to the camera and a few other sensors, and then sending that over pure WebRTC over the 5G network peer-to-peer to a laptop browser. And the only thing we're doing kind of in the cloud is the signaling. So we're trying to keep that peer-to-peer link for latency reasons, also privacy and cost. So that means that, like anything we have to do, it has to be at one end or the other. And so today's thing is about what we've done strange things that we've done in the laptop browser to try and, in some case, work around the fact that we don't have a media server. So yeah, here's example number one. There's somebody's Mercedes doing silly things. But one of the things that they did, I saw this photograph and I thought I instantly knew exactly which car that was because they put the camera in upside down. Because of the way that the roll cage was constructed, the obvious place to bolt the camera on was the wrong way up, which gave us a problem because our image was upside down. So I then thought, well, okay, well, where are we going to rotate this? In the media server? No, we don't have one. So then where do we do it? Well, initially we did it in the camera. And this was cute. You can use the G sensor to work out, like your mobile phone does. We use the G sensor to work out which way up it is and then rotate it as needed. Unfortunately, this didn't go down well when they rolled the car because you end up with the image the right way up when it shouldn't be. So we then tried to move it. No, I don't have a media server. We tried to move it, and I then moved it to doing it in CSS. So it's really nice. You can do a CSS transform, apply it to the video tag, and it just rotates it. Perfect. Except that the moment you press the full screen button or send it to a Chromecast, that strips off the CSS, and you're back the wrong way up again. So then we had the extreme case, and this did actually happen, that the easy thing to do is take the monitor off the VESA mount and turn it upside down. That works really well, but it's hard to justify. So we ended up with transforming the media stream track. Now, I should give a bit of credit to the concept of media stream track to Harold and Bernard, the late Bernard Aboba, who pushed for this in the W3C, and it's this quite nice abstraction for holding real-time media in the web browser. And what's interesting about it is that you can get a medium stream track from a ton of different places, and they all behave pretty much the same way. So you can create it, as some of you may already have done with and you do every day that you use Meet, Google Meet. It does calls get user media, and what get user media returns is a microphone track or a camera track, or both. The same thing is if you're painting pixels, you're doing some kind of drawing on your web canvas, you can capture those using capture stream on the canvas, and you get a media stream track. Same thing with media devices. So if you want to capture a whole screen or a window or a tab or something like that, it's kind of at the operating system level, media devices get display media, gives you a media stream track. And last but by no means least, your incoming RTP traffic that turns up in a WebRTC peer connection is also, in the web terms, in the browser, it's a media stream track. And they're all the same abstraction. So it turns out that what you can do, and this is relatively recent, what you can do with a media stream track is to transform it. You can say, hey, for every frame, I want to do something to it before I pass it on to the rest of the WebRTC, the rest of the web rendering engine. And in this particular case, what we're doing is we're saying, well, I'm going to create a new frame, but as part of one of the constructor arguments is a rotation flag. So I'm going to rotate this flag, this new frame, and I'm going to throw away the old one and pass the new one back into the transform. So we end up with a rotated frame, which is perfect. So it's actually quite a clean API. So you kind of have the transform written as one function, and then you pass it to a processor which applies it to every frame that comes in. So this is actually quite clean. So this is the first strange thing that you can do. There is a problem, though, which is that JavaScript is single-threaded. And so doing work like rotating things, rotating 30 frames a second, on that thread will impact the rest of the UX experience. It will make it sluggish. And modern laptops have got tons of cores, so surely it would be nice to run that on a separate core. So how can you do that? Again, surprise number two, you can do this in JavaScript. It is single-threaded, but you can have multiple single threads. You can create a worker which has in it doing something else. You can't draw to the screen, but you can do other stuff. And in this case, what you can do is on the main thread, you can say, hey, I'm creating a worker that will do rotation, pass that off, pass my rotation task off to this separate worker, and then my frames will get rotated in another thread. And so this works quite well, as I will attempt to demonstrate. This is a high-risk activity. So we have, with any luck, got a 5G camera. Come on, you can do it. Or not. Yes, there we are. There I am. So, hello. And I can rotate it. So if I click the rotate button, it rotates. And that's, what's interesting about that is like my mouse isn't sluggish. There's nothing else glitchy there. It's just working, which is quite actually interesting that you can achieve that without huge overhead. So, next problem, multiple viewers. Now, typically the way these things work is they take a screen and they put it onto the wall, and the crew stand around and watch it, and they watch the other monitors for all the other data as well. But there may be team members who aren't actually physically in the pit. They might be in the stands, they might be in the VIP suite, they might be somewhere else, or they might even just be a piece of AI software analyzing this. And all of those things still need a low latency feed, but we don't want to get it direct from the camera because that would double the 5G load. So the browser typically has a decent internet connection. It'll be on the local Wi-Fi, or it'll be Etherneted in or something like that. So what we can do is send a copy from there onto the VIP, and there'll be a bit of extra latency, but not a huge amount. But how do you go about that? Just kind of think of it as almost like an SFU. Well, it turns out that you can take a media stream track and send it, even if it's an inbound media stream track that's come from another WebRTC source. And you can do it even if it's being in use, being rendered to a video element, and send it on. So you can end up with this architecture that you get the stream from the car, you get it into the peer connection number 1 in the laptop in the pit, you draw that onto the video onto the wall, but you also send that one out, a second peer connection, to the VIP who's in a hotel suite or wherever. And this is done with actually not very much code. So surprisingly, that you can do this without having to kind of get clever about, I don't know, I actually thought quite hard about how I would do it, but it turns out to be really easy to do. And Chrome and the other browsers just sort this out for you, which is surprising thing number 3. So my next problem was, and I blame all the sports commentators for this, like they all wanted instant replay. Like, we want to see that thing again. Like, well, okay, that means I've got to record all of it forever, and just because you might want it. And where am I going to put it? And like, who's going to encode it? And stuff like that. So, and it's a load on, it's a computational and disk load that I wanted to try and avoid. And obviously you could do it in a media server, but we don't have one. So, then I thought, well, hang on, what about those video frames that I've been rotating and doing stuff with? Maybe we could do something with that. And it turns out that you can cache them. You can cache them in the worker. So what we do is we cache, I forget, a few minutes worth of the video frames and just sit them in memory in the worker. And nobody cares. And so you can just put them into a ring buffer. And then when you want them, you can get them out again. So, and if people don't want them, they're thrown away. And it costs a bit of memory, but nothing else. So that's surprising thing number 4. However, they want to save the replay, right? It's no good just looking at it. They want to be able to create a copy of it that they can send to a colleague or a race marshal or the social media people or whatever. So, and this is surprising thing number 5, with web codecs, I can take a video frame or an array of video frames, pass it to an encoder, which is completely different from the encoder that was used to send the video in the first place. It can be a totally different encoder. In this case, this is VP9, and that's H.264. So it's a completely different encoder, different bit rate, different anything you want, and you can just run it through this in a worker, so it's not taking load off the main thread. Run it through this, and I've skipped the bit that actually writes it to the disk, but you can write it to the disk. So, even more risky. I'm going to try and do that. So we have, yes, that was risky. So if we enable, no, yes, no, do rev. If we enable do rev, we suddenly gain, well, I say suddenly, it's got to reconnect over 5G. Come on, you can do it. We suddenly gain a button, which is the rewind buffer. Now, unfortunately, I've got to put something in it, so I'm going to kind of wave my hands around and do things so that it looks like there's something in there. So we'll do that for another second or two so there's something worth having. And then we press save the rewind buffer, and you notice that like the thing is still reasonably interactive. We're not, like, the fact that I'm stashing all this doesn't seem to matter much. So we'll open a rewind buffer, and it's still writing it to disk. It's still writing it to this. Come on. No, come on. Yes, okay. So now you can view it. And there I am. And I can press play. And you can see me doing the thing I was doing before. So, yeah, so you can do this. And whilst this has all been going on, the video is still live, right? We haven't lost it. So that was kind of interesting, the fact that you could do that. And now what we'll do is we'll save it. And I'll save it to a name I can remember because I might do something with it. So now we can save it and go back to our presentation, wherever it's got to. Right. So, okay, I've saved it. I've got myself a WebM, but maybe I wanted an MP4. Or maybe the social media people wanted a .mov. So normally what you do with that is you throw it to an FFmpeg server, or you'd either run FFmpeg locally on your Linux machine, or you'd throw it to something in the cloud that turned out to be actually an FFmpeg. But I don't have a media server. So, and the file's on the user's laptop, and I don't kind of want to install FFmpeg on everybody's laptops because that would be unpopular. But what do? Yeah, I still want to run FFmpeg because it's the obvious way to do it. And I'd like to run it in the browser. So you just get the WASM cross-compiled version, and there you go. You've got your sixth stranger thing is that you can actually do this. And this is so there's an proper API, and you can wrap it up so that it looks tidy, but actually you can also do it in a charmingly command line-ish way. So here is that. This is the WASMed FFmpeg running in Chrome, and you can give it now. You have to. It thinks it's. I actually have no idea how this works, but you can upload a media file. So we can upload our recent, if I can remember where I put it, users video probably. Movies, there we go. So there's our WebM. So we can upload that into the thinking space of this. And now, so that was, what was it? K world, no dash. I'm going to wish I'd copy pasted this, isn't I? Actually, it'll be here. Okay, worlddemo.webm, and get rid of that. And now, so I'm going to take that and I'm going to convert it to MP4, but I don't want to do the whole thing. Maybe I only want to take the last, I don't know. So that's minus SS, comma, and I'm going to start 10 seconds in. And I want to run for, I only want, I don't know, 2 seconds of it, because I'm already a bit bored with it. So, does that look plausible? No, it doesn't. There's no comma there. There we go. Right, so now this is going to run this command line. No, I can't believe I did that. I did, and it's gone. Right, anyway, I'm not going to put through that. Well, I'm going to let it do the thing that it already knows about, because that's more boring. But basically, you can run the thing, and it runs FFmpeg in WASM very slowly, about 10 times slower than it would do normally on the machine. But if you're not converting codecs, if you're just trimming or something mathematically simple, it doesn't matter. This transcode is going to take too long, but I will. If anyone actually wants to see that really working, I'm happy to demo it later. But I'm not typing live anymore. Right. So that's FFmpeg. running in WASM. So I want to summarize this in saying that like the web browser is a very capable real-time media engine where you can do really, I say they're strange, but they're kind of unexpected. It is not a SIP phone in your browser. It genuinely lets you get at the data, get at the thing, re-render it, do stuff with it. You can transform streams, you can run on separate threads, you can cache things, you can re-encode things, you can write things to disk, you can run any of your old Linux software that you want in WASM. I mean, really. Without needing a media server. So you don't have to have a media server to do any of this stuff in the cloud or anywhere else. So yeah, that's my little story. Very happy to talk to anybody about it afterwards, outside, whatever. Contact details there. Tim at Pipe, Steve Glinter, Chaos Social. I do consulting on open source, WebRTC, Pipe. Actually also on W3C and the ITF. And I should give image credits there. The images for the countdown thing, count up, whatever, are actually Stranger Things posters you can buy from Netflix. And the Merc was at the Dubai 24-hour rally, and it was one of the PR photos. Now, I'm going to put these in because they help me here, because I am a bit deaf.
Okay. Okay. Thank you, Tim. So, time for questions. We have Yuri back in the corner.
That might be not exactly a question, but there is a video rotation RTP extension header, which you can path, and then you will be able to rotate video right on the fly after renegotiation. So that's a little tip for you.
So
instead of doing this in JavaScript, it's a built-in into the RTP.
Yeah, the question then is, how does it know? It needs to be a user request.
It sends.
So you'd have to send a data channel message to the far end, yes, to the camera, to say, hey, set a renegotiation. And then you do an offer answer, and then maybe Chrome would render it the other way up.
Yes.
Right. This is quicker. Like, this is a single click, stays in the browser, and it doesn't have to do a round trip, two round trips.
This is expensive, more expensive in your case, because of you doing rendering and then re-rendering. Because if you receive Chrome and then re-render it.
What I didn't say was that Chrome actually optimizes that, because what it does is it sets the bit in the codec header, which says, by the way, this is rotated. It sets the 3GPP rotation flag. So although I did that in a worker, I didn't need to, it turns out, in Chrome, because Chrome just sets the flag. So it's actually a low energy activity, and I can do it locally. I don't have to round trip. But yeah, I mean, if the camera knew which way up it was, then perhaps that would be the right way to do it. But there's no switches or dials or anything. There's no settings on it. It's a dumb box, as dumb as we can make it.
It's not a dialing, it's standard. So if you use WebRTC, WebRTC library is already supported. And if that built-in camera, so it's just runs.
Yeah, we could.
You can, but
no.
Yeah.
Okay, so we have Fred here.
How many connections are you running on a camera like that?
How many connections? In what sense?
Well, like you said that there's like people in the pit and then some other people. And
Oh, it's very limited. Like, I think the most we've ever had of the VIPs and that's is like 6 or 8. We're not, like, it broadcast is a whole other thing. That's another game. Typically, there's only one viewing station, and that's in the pit wall. It's just in exceptional cases they have like an investor or you know, the brand consultant who's swanning it up with champagne in a hotel room and needs to see it. So it's a very small user group, and deliberately so.
Okay, for further questions, you'll be around, not too delayed because we started with some delay and then the panel took a bit longer. Thank you, team. Really appreciated all sharing all this